Welcome everybody to a new Innovators update with me, Richard Hulskes, co-founder of Revolver, and Rachel Gordon, communications and media coordinator at MIT. In this session we discuss the latest research that's happening at MIT. I'm going to get Rachel into the call. I think she's connecting right now. She promised us a lot of new research that was happening at MIT, so I'm very excited to talk with her. We postponed for 1 week. Hey Rachel,
hello. How are you?
Good, it's good to see you. We missed you.
Good to see you.
A week later than usual.
Yes.
And you promised us that there was a lot of research coming out, so that it would be best to wait. So
Yes.
I think we're all very excited to hear more. How are things on your end? How are things at MIT? Are they picking up steam again?
Yeah, everything's great. We are actually in phase 3 of our research ramp up, and we're lifting the current cap on the aggregate number of hours that laboratory personnel can be working in the lab, but we are keeping our stringent COVID regulations in relation to density and distancing to ensure that everyone is still safe, but getting to conduct the research that they need to do.
Okay, good. Well, that's good news for us because that means we'll be able to see more come out.
How's everything with you?
It's good, but like our country, we're going back to COVID-wise, we're doing really bad. So we're slowly shutting down again. But you know, I wasn't leaving the house too much anyway. So I just keep doing my thing, and everybody in our team is remote, so we're dealing with it pretty well. And so far, I think there's a lot of infections, but not too many people that die. So
okay,
we'll see how it goes. It is what it is. Let's just dive into the first article, Rachel. This article explains how artificial intelligence can become more efficient by mimicking biological models. That was a mouthful, but it sounds really interesting. Can you elaborate on that one, Rach?
Yes, definitely. So mimicking and modeling artificial intelligence after the human brain has been in development for nearly 80 years. And for example, in 1958, Cornell psychologist Frank Rosenblatt began work on the perceptron, which is largely considered the first neural network. And this was inspired by the operation of the eye of a fly in determining its flea response. So a lot of this work that has progressed over the past 80 years has actually harnessed massive amounts of computing power available. And deep learning now has been used for robotics and computer vision tasks and image recognition. But new research has shown that simpler, smaller neural networks can be used to solve certain tasks more reliably and more efficiently than ever before. So our researchers created a new artificial intelligence system based off of the brain of tiny animals such as threadworms. And similar to living brains, artificial neural networks consist of many individual cells or nodes that process information and patterns and tasks. So the team wanted to test their system on a task that seems very difficult for humans, which is cars staying in their lanes. They use self-driving cars, of course. So this is how it works. So the neural network receives camera images of the road as input, and then the control part of the system, which is called neural circuit policy, translates the data from the perception module into a steering command. So then the system can, once it has that information, the system can automatically decide, okay, should I steer to the right or should I steer to the left? And this used just 19 artificial neurons.
Wow.
Yeah, so that's pretty crazy. So this experiment demonstrated that the role of every single cell at any driving decision could be identified. So this model allowed the team to investigate what the network focuses its attention on while it's driving. And in this case, it was the curbside and the horizon. So the processing of these signals within these individual cells in this specific system used different mathematical principles than previous deep learning models that focus on large amounts of data and large amounts of computing power. So this has a lot of advantages over previous deep learning models, as it deals much better with environmental disturbances and noisy input. And because of its simplicity, it avoids the classic black box problem where interpretability can't be explained. So it's really a new exciting project.
All right, and then Rachel, next to like you know, keeping us driving in one lane, are there any other potential applications that these smaller networks could be used for?
Definitely. So this degree of interpretability and robustness is basically impossible for larger deep learning models. So this has a whole range of applications, from automated work in warehouses to robot locomotion. And what's really exciting here is that interpretability and robustness to being able to understand why it's making decisions.
All right, wow, interesting. Okay, cool. And so in the next article, Rachel, one that I find really intriguing, it talks about 1 in 8 US deaths is caused in part by heart failure, which is wild. And in this article, you talk about how we can anticipate heart failure by using machine learning.
Yes, so this research project is in the line of computational biology research that I've been talking about in a few of our previous episodes related to using computer science for better health diagnostics and
let's see.
okay.
Yeah, this
little
is
technical difficulty there.
It happens. You can, I forgot where we were, Rachel.
We were talking about computational biology tools to help with health diagnostics.
There we were.
Yes. So I'll just jump right back into it. So every year, roughly 12.5% of deaths are caused in part by heart failure, and that's according to the CDC. And one of the telling signs of this is excess fluid in the lungs, which is called a pulmonary edema. So the amount of fluid in the lungs can determine the course of treatment, but normally this hinges on subtleties in X-rays that can be hard to tease out. So to address this, a group of researchers came up with a machine learning model that can look at an X-ray to determine how severe the edema is on a 4-level scale ranging from 0, which would be healthy, to 3, which would be very, very bad, which is how my mother describes my diet habits. So the system determined the right level more than half the time and correctly diagnosed level 3 cases 90% of the time. So better edema diagnosis could help doctors not only manage acute heart issues, but also things like sepsis and kidney failure, which are associated with the edema. And this could also provide some really interesting retrospective analysis. So the model was trained on chest radiographs and their associated radiology reports, pulling from a data set of over 300,000 X-ray images and their corresponding text written by radiologists that they had amended and adapted. So the team plans to integrate this system into Beth Israel Deaconess Medical Center's emergency room workflow this fall, and they also worked with Philips.
All right, cool. Well, some Dutch pride in there with Philips. All right, interesting, Rachel. And so in the last article, we want to talk about a new glove that's been developed, which lets users incorporate real-life objects into the virtual worlds. And I think, like in the world we are today, this might be something that's very relevant, I guess. Can you tell a bit more about that project?
Yes, I'm just going to add one more thing about our previous project. So the system also had to account for varying tones and terminology used by radiologists, because in every profession there's normally a standard vocabulary that is used by the professionals, but many people deviate from that, and they have different experiences and backgrounds and training that influence how they communicate using that specific vocabulary. And in this case, it would be a medical vocabulary. So the researchers developed a set of linguistic rules and substitutions to ensure that the data could be analyzed consistently across reports, even if they are missing a label related to how severe the edema is.
Oh, wow. All right. Wow, interesting. All right, cool. Okay, so back to the glove.
Yes.
So this is a glove that's been developed recently, yeah, again, super relevant to today. I think AR VR, it's definitely making a push forward. I think
Yes.
the pandemic is obviously helping with that. So yeah, tell us a bit more about the glove.
Definitely. So we've all become really familiar with smart technology that measures our biometrics and our wellness behaviors and our moods. And it's typically found in things like watches and rings, and was very much popularized by the Fitbit, which oppressively said we should walk 10,000 steps. And I think I'm averaging about 5 every day.
It's getting less and less, yeah.
Yes. So recently, a group of scientists from CSAIL came up with a different approach to this smart technology in the form of a glove. MemGlove can accurately measure the state of all of the joints in your hand to state-of-the-art precision. And specifically using this glove, the team was actually really surprised by just how much they could measure. Temperature, force, stiffness, conductibility, heart rate, grasped object classes, and even handwriting. So here's how the glove works. It has 2 types of sensors, resistive and pressure sensors. So the resistive sensors give a lot of information with sparse input. And the glove is fully conductive, and there are electrodes on a few points on the glove. And as the glove is stretched and bent, the resistance changes at different points in the glove, which contributes to accurately reconstructing the probable hand pose. So you can imagine using a smart glove like this for things like AR and VR environments, gaming, robotics, and even medical diagnostics. And it can actually even tell which letter of the alphabet a user is writing. And they only tested A through J so far, but they actually achieved an 85% accuracy rate on that task. And there's many circumstances. So along the lines of, is this cumbersome? Why would I want to be out in public wearing a glove? I don't want to look like certain late singers. There are many, because the rings and watches very seamlessly integrate into our life, because that's jewelry. People already wear that. Yes, people do wear gloves in the winter, but what if you're in a more tropical climate? So there are many circumstances, though, where people already wear gloves, in which case sensorizing it could provide some real-time capabilities and data collection, such as if it were being used for health monitoring or fitness training.
Yeah, and what I like about the project is also that, the hardware is already there, and of course it needs to be iterated on, but it works. But the software obviously is something that can even develop much faster and get much more, have much more applications than that it has now. And I think what was surprising to me is that, what I read is that it can be commercially developed for around $60. How did they do that? How did it make it so cost effective?
So the reason it's so cost effective is because all of the components are off the shelf, and it's all textile based, and textiles are cheap. The glove substrate is a few dollars, and the cost of the wires, electrodes, and pressure tubes all also only combine to a few dollars, which is less than my matcha latte that I get every morning. So
it's true.
Unsurprisingly, the most expensive part of the device is the electronics, and the most expensive part there is the pressure transducers. And a transducer just converts energy from one form to another.
Yeah. All right, gotcha. Okay, cool. Well, we're already through all the research for this week. You promised us a lot was coming out. Can you already give us a little teaser for what's coming up?
Definitely. So I can't go into specifics. We will see the specifics soon enough, but we have some really interesting projects in the pipeline about 3D printing and design, another robotics project, and another computational biology project related to more health diagnostics, leveraging machine learning.
Yeah, gotcha. All right, cool. Well, enough to wait for. We're going to check in again in 2 weeks. As always, this one will live on our Instagram. It will also be shared as a podcast later. And you can also go to evolve.com, look for MIT or look for Rachel Gordon, and find all the articles that we discuss. Sharing as a podcast on Apple and Spotify. And I think that's kind of it for now, Rach. What do you think?
Yeah, what's anything else new going on with you guys down the pipeline?
Oh yes, a lot. So we are going to share. Well, we have been sharing tons of new research from all sorts of universities. A lot in the US. It's definitely noticeable that everything's starting up again. We're working on getting more universities in the United Kingdom on board as well. So that's something I'm really excited about. And yeah, we're going to push a lot of new content that we've been created, especially around AI, in the next few weeks. And we are developing two big challenges. We just finished a 3D printing challenge, and there's two big ones coming up that we'll be announcing in the next few weeks. So a lot happening as always. So yeah, exciting things.
Wonderful.
Cool. All right, Rach, we'll talk in 2 weeks again.
Sounds perfect. I can't wait.
Yeah, me too, and have a wonderful weekend.
Thank you. You too.
Bye-bye.
Bye.
Bye.